Hello everyone. So this is my first video which I'm creating, and for today I'll be solving this Leetcode daily challenge, and I have actually already solved it, but I'll record it now. So the question states that we have to find the largest value in each tree row. By each tree row it means that we have to find the maximum node value at every level. So if you must be already familiar with level order traversal. And if you see, this is the first level, this is the second level, and this is the third level. And you can already identify that the maximum value at the first level will be the root itself. So there's no issue in that. And if you see the second level, you have to iterate on every level and have to compare with the current maximum value whether 3 is the maximum or not, whether 2 is greater than the current maximum or not. So at the end you will find that 3 would be the maximum value at this level. Similarly, in the last level you can see that 9 would be the maximum node value at the third level, and this is what you have to return. If you see the output, this is what you have to return, right? So it's a simple question. We'll follow the normal level order traversal here. And if you see the constraints here, the constraints says that it can be empty also. So we'll have a check if root, if not root, we'll simply return empty vector, right? Otherwise we'll create a new vector for answer. And for level order traversal, you must be knowing that we need a queue data structure. So we'll create a queue, right? And we'll push the root in the queue. So if you see the algorithm, this is our queue, let's say. And in the first iteration, let's draw it. It looking like a stack. So let's draw it this way. So let's say I pushed one in the queue, right? And what I'll be doing is I'll find the current size. The current size is 1. So I'll iterate on the queue for one time and I'll pop it out. So the current element would be 1, and I'll compare it with current level. I'll maintain a current max which will initially be current int minimum minus infinity, let's say. So since this is greater than my current max, I will assign it in my current max. And at the end of this loop, I will find that 1 is the maximum value at first level. So I will also maintain an answer variable and I'll push it in the answer. So 1 is popped out, and also I will push the children of 1. So 3, this is popped out. 1 has left child, so 3 is pushed. 1 has right child, so 2 is pushed, and we return. In the next iteration, we'll come and we'll see that the queue size is 2. So we'll do the task for 2 times. So now 3 will be popped, and again current max would be minus infinity. So we will be assigning a local variable current maximum inside the inner loop, and 3 will be compared with minus infinity, and 3 would become current max, and then 3's children, which is 5 and 3 again, will be pushed. 3 will be popped out. Now 2, 2 gets popped. 2 is compared with 3. It's not greater than 3, so current max remains 3, and 2 is popped out, and 2's children, which is 9, is pushed in the queue. And we see that the current maximum level, the current maximum node is 3. So we push 3 in the answer. We come out of the inner loop. Then we again see the queue size. It would be 3, right? So we'll do the task for 3 times. Now we'll pop 5. 5 is popped. We'll see that current maximum is minus infinity because we must have initialized it with minus infinity in the inner loop. So now current maximum would become 5. 5 has no children, so we won't be pushing anything. Now 3 gets popped. 3 is smaller than 5, so we won't be doing anything, and current max remains 5, and 3 does not have any children, so we won't be pushing it in the queue. Now 9 gets popped. 9 is greater than 5, so current max would become 9 now. And at the end, we'll see that 9 is the maximum node at this level. This is what we have to do. So now let's write the code for it. While not queue.empty. So as I showed you in the dry run, we first found out the size of the queue, and we also maintain a current max. Let's assign it with some very minimum value, and we'll do the task until the current queue size. And we fetch the first element and pop it, and now we checked whether the current max is the maximum value or not. So we'll compare it with the current node's value, and if current node has child, we'll push it in the queue. If current node has right child, we'll also push it in the queue. And once we are out of this inner loop, we would have traversed the entire level. If let's say we were at this level, then we would have traversed this level, and these although these elements would have been pushed in the queue, but the current max would make sure that we have the maximum value up till this level only, because we are iterating until n minus minus. Because when we entered this first loop, the queue size was 2, and even though we have pushed multiple elements in the queue, we have only worked until 2 times. So now all we need to do is push this current max in answer, and at the end return answer. Let's test it out. Let's try to submit it now. Yeah, so it's working fine now. The Let's see the time and space complexity. As you are already aware, that space complexity of the level order traversal is order of n at worst, where n is the total number of nodes, and the time complexity is also order of n, where n is the number of nodes. So that is all for today.